Hey class, welcome to Chapter 8. We're going to be talking about chemical equations in this chapter, and chemical change as well. So before we get started, remember that if you're looking at a chemical equation, this is a way of describing a chemical change that has taken place. So here on the screen, I have an example of a chemical reaction. Reactions are going to be used periodically throughout the semester. We're going to be seeing a lot of different chemical reactions or changes taking place with chemicals to become new chemicals. So we need to understand how to read first a chemical reaction. The first thing you'll see is there's always some atoms or elements or molecules written on one side of the reaction and elements or molecules written on the other side of the reaction. And in between there's an arrow. So we need to understand how to describe things to the left of the arrow and to the right of the arrow. The things that are found to the left of the arrow are always called reactants. These are the elements or compounds before they become changed, so they're going into the chemical reaction. The arrow indicates a chemical change, and then what's found on the right-hand side of the arrow are the products, or what comes out or is produced by the chemical reaction. Products. Okay, so we always write chemical equations this way. Sometimes I'll see students early on, usually before we talk about chemical reactions, and they kind of seen a chemical reaction before, so they'll try to put them together, and sometimes they accidentally put the reactants on the right-hand side, and they'll reverse the arrow and they'll put the products on the left-hand side. This is not how we show the chemistry from going from reactants to products. It absolutely matters which way the reaction is written. It's always reactants on the left, chemical change, and products on the right. Alright, so left to right, just like you read. Alright, what else do we need to know about chemical reaction? Do you see in this chemical equation we have written here, in the equation there are numbers, not always, but in this case there are some, written before some of the reactants and products. These are called coefficients. They're the whole numbers that are written not as subscripts, but just as generic type and standard type before reagents in a chemical reaction. Coefficients are always whole numbers in a chemical reaction, so you'll never see like 1.5 or something like that. They're always whole numbers, and that's because they indicate the number of each substance participating in the reaction. This chemical reaction up here, if we were to read it, now that we know our nomenclature, we can read the chemical reaction left to right. It says 4 atoms of aluminum plus 3 molecules of oxygen yield 2 formula units of aluminum oxide. It's kind of like a recipe. In a recipe, you always have your ingredients and then they produce something. So when you make a cake, for instance, you've got 3 eggs, a box of cake mix, some flour, and some water. And those produce 1 cake. So 3 eggs, 1 cake. Those are what those coefficients stand for, the amount of each reagent, either that goes in or is produced. The third thing about a chemical equation that we need to understand is the special conditions sometimes. Special conditions of a chemical reaction. And this is not always the case, but sometimes some reactions need special conditions in order to go. Like if you put the 2 reactants together, nothing would happen unless something else occurred. For example, in this reaction, notice above the arrow I have a triangle written. The triangle written above the arrow in this instance means that we're adding heat to the reaction. This is how chemists would symbolize heat being added to a reaction. If we did not have the symbol here for heat, the reaction wouldn't take place. It's needed. So if you added aluminum and oxygen together and you didn't have heat, nothing would occur. However, if there's heat, you form aluminum oxide. This is not the only special condition that's usually use. Sometimes there's certain types of catalysts that can be seen above arrows, or maybe you need an oxidant or an acid. So you'll see many things written above arrows in the class. Just know that those are special conditions. And the very last thing we need to talk about for chemical equations, things that we need to know when we see one, are that the physical states are sometimes indicated. The physical states. My voice. Oh no, my voice is going. Now remember, we've talked about a physical state before. Physical states indicate what state of matter the element or compound is in. And this can be helpful sometimes when you're looking at a chemical reaction to understand what the reaction is like. So in this reaction, for instance, notice there's a solid, there's a gas, and there's a solid. So aluminum is a solid. When it's added or combined with the oxygen gas, it produces a solid aluminum chloride. So those are the general physical states, solid, liquid, and gas. So we've got solid, liquid, we've got gas. But there's also some other physical states. Sometimes when things are not pure substances, but they're mixtures, we can write that as well. So, for instance, if something was dissolved in water when you used it in a chemical equation, we would say that that thing was aqueous, or it was a solution mixed in water. And aqueous, the symbol is AQ. If you have a solution of a substance, generally you'll use aqueous if it's water, but if there's some other substance or solvent that the substance is dissolved in, you might just want to call it a solution in general instead of just a pure substance. And solution is SOLN, so solution. So these are things you might see. You don't have to put the physical states inside a chemical reaction, so you'll notice not all chemical reactions will have the physical states written, but you'll see them in there. Oh, there was one more. Sometimes instead of just saying that you'll make a solid, if the solid drops out of a solution, so let's say you have a solution where everything's in the liquid state or is dissolved in water. If a chemical reaction occurs and you notice a solid drops out of that solution, we're going to call that a precipitate. And a precipitate is PPT. So that's another one you might see.